My name is Smrekar. My position is Principal Investigator for the VERITAS mission, and I work at JPL, the Jet Propulsion Laboratory in Pasadena. I took a little bit of a circuitous path towards arriving at my career. I loved math when I was a kid. I loved being outside and hiking and doing anything outside pretty much. I went to college. I didn't know what I wanted to do. I tried physics. I tried anthropology. I kind of tried astronomy through an internship. And then I've hit geophysics. And that was what I fell in love with because I could write equations that describe how do mountains form and stuff. And then I found planetary, and then I found I could do planetary geophysics. This is so cool. It's like I can do space and geology. Basically, at the start of the space age, there were a ton of missions to Venus, just a ton. The Soviet Union was throwing spacecraft one after another at Venus. So it was the it planet when we first started exploring space. In part it's close, in part it's the same size as the Earth. A lot of exciting scientific questions. Okay, and then we had like the Magellan mission in the 90s, and there was this big controversy. Was it geologically dead or was it active? And a lot of people came down on the side of it being geologically dead. Okay, that was the paradigm for a long, long time. And that slowly changed over the last 10, 15 years. The European Space Agency sent Venus Express to Venus, which was meant to study its atmosphere primarily, but it also was able to see the surface. It was kind of the precursor to the Venus emissivity mapper that will fly. From that data, we got evidence that, there have been recent lava flows on the surface. So, that's like kind of maybe it's not dead, right? And more bits of information and just kind of there was kind of a paradigm shift to realizing that Venus is very likely active. I find Venus to be just incredibly fascinating because Venus and Earth probably started out very similarly, in terms of their composition, but now they are entirely different, right? Venus is hellish, Earth habitable. For me, a super big question has always been, why doesn't Venus have plate tectonics, and what does it have instead of plate tectonics? What's really going on from the whole scale of the planet? People say, how does the planet lose its heat? Which sounds like kind of a boring question, but it's really like saying, how does it operate? Because planets are like big engines. With Earth, it has the plate tectonics, which brings the heat up from deep inside the planet, and it manifests as the tectonics, the mountains, the valleys, the volcanoes. So the question is, what's that system on Venus? Well, one thing that the VERITAS mission is going to do is bring Venus into the 21st century. Okay. The last time we took global topography and radar data for the planet, that was when there were dial-up modems, right? Since then, we've gone back to all the rocky bodies in our solar system and taken these beautiful data sets at much higher resolution, right? And we can do that now for Venus again. With Venus, topography is super important because we can't take visual images, and radar images tell us a lot of information, but they're just not the same as visual images. So you can have two lava flows right next to each other, and unless they have a contrast in their properties, we can't tell them apart in radar. But we can see their contours in topography. So I am the principal investigator. And, that's kind of the buck stops here job. I have to be ultimately responsible for delivering the most science per dollar of the mission that we possibly can, as well as, setting the tone for the mission. Like, how do we interact as a team? How do we represent ourselves publicly? What's the kind of the value that we're creating on many different levels? It's very broad, in that I work with the engineering teams to make decisions about, what size memory do we need? How long are we going to be observing this versus how long are we going to be observing that? I work with a science team and, make sure that all of their viewpoints are represented, that everyone gets to do, valuable science and contribute to the mission. I work with, the public outreach people to make sure, the public gets excited about our mission. and with management at JPL, at NASA headquarters, to make sure we're giving them the information they need about our mission. And they want to know that we're, making good progress and spending their dollars wisely. Yeah, VERITAS has only 2 instruments and what we call like gravity science investigation. So, with these 2 instruments, plus our telecom system, we get all those different kinds of data sets. So, like with the telecom system, when the spacecraft is flying around Venus, whenever there's more or less mass, the spacecraft velocity changes slightly. So that affects its speed, which affects its Doppler signal in the telecom transmission. So basically, from pulling out these tiny little variations in the speed of the spacecraft, we can get a map of what's going on inside the planet in terms of the density variations. And we'll also contribute to that by assessing how does the planet wobble, which tells us about the interior. So, the classic experiment is take a hard-boiled egg and a raw egg, and you put them on the table and spin them, right? They spin differently, because of what's going on inside the eggs, like the liquid egg wobbles around. And so we use that kind of information about wobbling of Venus to give us information about, like I was saying, the core size. So we use both the telecom system and we use our radar data, because the radar data is always flying over the same points repeatedly. And so that gives us kind of like a tie point on the surface. It's kind of like, okay, we knew where we were at this point one time, second time, third time, and that kind of gives us a grid of points on the surface that help us with tying down the wobble of the planet. Then with our radar antenna, it's called VISAR, Venus Interferometric Synthetic Aperture Radar. It will take data at X-band, which is about 4 centimeter wavelength. And so, basically it sends a radar signal out, and it has 2 antennas, and the signal is received back at the spacecraft on those 2 antennas. And what happens on the surface gives us a lot of different information. So if the surface is really, smooth, like a parking lot, the radar wave comes in, bounces away. That will appear relatively, the way data is processed, it's shown as dark, radar dark, which means smooth. But if it's really rough and a lot of facets and topography comes in, and all the radar bounces all that back. So that gives us the radar image of the surface, which is what we've been looking at on this globe. There's a lot going on between now and 2031. Certainly on the engineering side, there's a ton of work going on. Our international partners, the German, French, and Italian space agencies, they've been doing a lot of work. Some aspects of the spacecraft, some of the instrumentation and so forth has already had what they call the preliminary design review, and others are going to be coming up in the next year. So basically, we spend a lot of time refining the designs and testing a lot of different aspects. Yeah, some of the things we do for the preliminary design reviews are, see how well does it respond to shock, because, when you launch something on a rocket, it experiences a lot of shock. So we make sure that the parts that we're using and everything are going to stand up. That's on the engineering side. On the science side, we're doing a lot of things as well. Last summer, we went to Iceland and had a field campaign, which is super valuable. Say, okay, this is this lava flow or this fracture, and this is what it looks like in the radar data. So you have kind of this visceral understanding of how is radar related to the surface, because it's not unique. You can't just look at a radar image and know everything about what's going on at the surface. Yeah, working in VERITAS is extremely rewarding in many, many aspects. Scientifically, for me, I've spent decades studying Venus, and I believe this mission will just answer a number of super fundamental science questions that are important, not only for understanding Venus, but also understanding the Earth, like how did plate tectonics start on Earth, and for understanding exoplanets, because if you regard Venus and Earth as you would two nearby exoplanets, you can't really tell the difference. I think we'll learn a lot about trying to understand rocky bodies in our solar system and other solar systems. So scientifically, it's going to be amazing. It's also been extremely rewarding working with so many people over the years. We've taken a long path to get VERITAS selected, and just built up tremendous relationships with people in, like I said, we have Italians, Germans, the French, they're all supporting this mission too. And, we just have awesome colleagues in all of those places.